Okay, so the next problem in the lead code we are solving is to delete the middle node of a linked list. Okay, so basically what we are trying to do here is like we'll be given a linked list. Okay, and we'll have to delete the middle element. So this is the list, and there are a number of ways. Like I mean, if you want to go with like I mean, the first approach would be like what we can generally do is we can iterate through the list. Okay, and we can get the length of the linked list. Okay, and then we can divide it by two. Like I mean, we just need a quotient. We should not be needing the we don't be needing the reminder. Okay, like I mean, so it would be like length slash slash divided by 2. Okay, not just slash. Okay, so we'll get a length and we'll get a node element, and then we can iterate through this linked list and get that middle element, right? We can get that middle element and we can just pop it out. Correct, that is one way. So this was the way that I was using previously. Okay, so what we have done was this is explicit handling for 1 and 2 node. So calculated the length, I'm just showing you, we'll just go to the simplified way quickly. Okay, so this way we calculated the length here. We'll start it from 1 and we'll be incrementing it, and we got the length. And now we found it how many times we'll have to jump, like I mean, to get the middle element. Okay, so once we got it, so we'll jump it till that point. Okay, and then finally remove the middle node by, if you are at this some point in time, we'll be here, right? We'll be just pointing our node to dot next. Like I mean, current node is this, right? We'll be pointing our node to that, so this node will be removed. This is one way, like, which will obviously will have a time complexity, because we'll be iterating through the linked list again and we'll be coming back, right? It will be like n plus of, correct? So instead what we can do is uh like anyway what we can do is we can use the two pointers here. One is fast pointer and slow pointer. Okay, like what I am observing is, let's say that if I need a length, right? If I need a length at some point in time to do my calculation, so ideally we'll go with the slow and fast pointers. Okay, to approach, like let's say that if there is some other condition, currently it is the middle element, right? There can be something else in the future, and ideally, instead of getting, like in the previous method, what we have done is like we have done a calculation for to calculate the length, and based on that we calculated a length, right? First we calculated the length, and based on that we reiterated, right? Whenever we are doing that, we can think of if it can be approached using a slow pointer and fast pointer. Okay, so now let's see how this is helping here. So slow pointer and fast pointer, we have set it to this. So what does it mean for first place, right? Slow and fast, like what we'll do is now we'll iterate through it. Okay, and instead the slow pointer will be updated only one step. Like let's say that for each iteration we'll be updating slow pointer to one by one step. Okay, but fast pointer will be updated two steps. Okay, so for the first time we are pointing both our slow pointer and head pointer here, and it will be going here. Okay, like I mean, slow pointer will go here, 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 here. Okay, but fast pointer will jump two steps, it will go here. Okay, so what does it mean is, let's say that it is like a race kind of thing. Okay, so if a person X is having a 5 kilometer per, like I mean, some racing 5 kilometer per hour, and the other guy is having exactly 10 kilometer per hour. Okay, so now if we start the race line, okay, if they are going at the same speed, obviously when the fast pointer reaches the destination, right, this slow pointer will be exactly in the middle, because it's an ideal condition that 5 kilometer per hour and for 10 kilometer per hour. But if that is exactly true, right, so what will happen, like once the first pointer reaches the destination, slow pointer will be exactly in the middle, right? So now we know what is the middle element, and if we kept a track of what was the, if we can get the previous element, right, we can just point it to here. That is our logic here. Okay, so we can just remember the race theory. So slow pointer, both are starting from the same point, and at some point in time we got to the middle element, but we want to know the previous element, right? Because to point it here, so just we'll have that previous node. Okay, so now we'll iterate through it. We'll have to iterate until the first person completes the race, correct? So we'll need a fast node, and if there is anything in the next, right, there is if there is any node, we'll have to iterate, and we'll keep a track of the previous node for the load slow node to replace it at the end. And finally, once we have once the fast has reached, right, this will loop will break, and we'll just update it. Previous dot next is equal to previous dot next text. Okay, and finally once we have updated this node, we whatever the head node that we had there, right, that we will return it. Okay, and we'll have to also handle the case for length is equal to 0, length is equal to 1, but here it's been given that length will be 1 actually. So you can ignore for length is equal to 0, but length is equal to 1 is needed. If it is not head dot next, right, like there is no node, uh, here it is being given that if it is n is equal to 1, right, if length is equal to 1, we'll have to remove the node at 0. So we'll be returning the none. like it's like a empty linked list. There is no linked list as such. Okay, that's it. Thanks.